Hello, this is Mr. Collier, and today we're graphing quadratic functions. Okay, so let's take a look at, well, first of all, there's three forms. You can have a quadratic written like this, we call that standard form, and obviously the y-intercept is going to be whatever this value is, because if you substitute in 0, you get the y-intercept for any function. Factored form, also called intercept form, looks like this. It's factored. And if you solve this equal to 0, obviously your x-intercepts are going to be alpha and beta. So we call that intercept form or factorized form. And alpha and beta are the x-intercepts. And finally we have vertex form, which we're going to talk about in a second, what these terms mean after we do some graphs. Okay, so first of all, let's take a look at some graphs here. Yeah, we got y equals x squared as a regular function, so you can make a table for y equals x squared, and let's include some values like this. So x squared is going to be 0, 1, 4, and 1, 4 this way. So we get the same values to the left and the right of 0, and it causes you to have this graph right here. And even if we go one more and do 3 squared, we get 9. So it's not linear, it's a curve that looks like this, which is called a parabola. This shape's called a parabola. Okay, yeah, so it gets steeper and steeper and steeper as you go to the left and the right, but this goes on forever, hence the arrows. Okay, that's what that graph looks like. Now for part B, we have this table. Let's do the same numbers, 0, -1, 0, 1, 2. And 0 squared. So we can basically take all these numbers here and subtract 3, and we get 1, -2, -3, -2, 1. So same kind of thing, it's symmetric, and the y-intercept is 0, -3, so it's down here. And you get the same kind of thing. You go over 1 up 1 here, and 1 over, and you go up 4. It's the same kind of thing. You can also look at the graph, and you can subtract 3 from the y values that you see on the previous graph. 1, 2, 3. So this is what this graph looks like. And actually, it will never touch the red one. This is y equals x squared minus 3. All right, so you can see because we're subtracting 3 from all the x squareds, the whole graph gets shifted down 3. And actually, we call that a translation. Translation of 3 units down. Translated 3 units down. Okay, and maybe I'll talk about some of the vocabulary up here now. See, the axis of symmetry is the line that goes straight down the middle. In this case, it cuts it into 2 equal pieces, hence the name axis of symmetry. So x equals 0 is the axis of symmetry. I believe there's 2 m's. Okay. All right, let's look at another example. I should have done the first graph in blue. I don't know why I didn't do that. For number C, we can just add 4 to our previous y values. You can fill out the table if you want to, but it's pretty easy to just go to this red parabola here and just add 3 right on the graph, so, or add 4. 1, 2, 3, 4. So I'm just getting this y value of 1, and I'm going to go up 4, and we're here. And if we go up 4 from there, we are right here. So that's the graph of y equals x squared plus 4. And then, of course, y squared minus 7. You just take the original function, by the way, which we call the parent function. Call that the parent function. And then we go down 7. It's translated down 7 units. So we'll go down to it'll have a y-intercept of 7, and then the same kind of thing. Yes, over 2, and then up 4, right? Okay, so it's going to go like that. Should be curvy and not pointy on the bottom. So let me try to draw that a bit better. Okay. So that is y equals x squared minus 7. So you can see this number on the end affects what we call the vertical translation, the up and down. Okay. So this corresponds, and it also corresponds to the vertex. Okay, the vertex, the y value of the vertex is at k, basically. All right, so yeah, if we have a function y equals x squared plus k affects the vertical translation. Affects the vertical translation. Okay, let's take a look at this one. We know x squared looks like this. 2 squared is 4. So it looks like that. And 3 squared is 9. So we got our parent function again. Okay, x minus 3 squared, well, let's check that out. If I got 0 and I substitute in here, I get, if I substitute in 0, I will get a 9. If I substitute in 1, you're going to get a 4. If I substitute in 2, you're going to get 1. Substitute in 3, I get 0. And here's what symmetry is going to happen then after at 4. Substitute in 4, I'm going to get 1, and you're going to get the same values again, 4, 9. Okay? So this is the center, this is the vertex, because the symmetry happens to the left and the right of that, right? So I'm going to graph that. Now the vertex is at 3, 0, and you're going to have the same kind of graph happening right here. This should be up at 9. So actually the y-intercept is 9. Okay. Y equals x minus 3 squared. So it's x minus 3 gives you a horizontal translation, 3 to the right. Okay. Horizontal translation, 3 right. Okay, let's check out C, y equals x plus 6 squared. So I'm going to put in negative 6 here in the middle. So I know if I plug in negative 6, I'm going to get 0. Okay, and then bigger than that is negative 5. Substitute that in, you're going to get 1. So you're going to get the same numbers like this. Okay, so we're going to go over the vertex is going to be at negative 6, 0, and you're going to get the same parabola shape over here. Okay, so that is a positive 6, but we go negative 6 on the graph, basically. We go to the left 6, okay? So H affects the horizontal translation. But you got to remember that it's the opposite sign. If it's a plus 6, it's to the left 6. If it's minus 6, it's to the right 6. Okay, let's look at another one now. Now we have a number in front of the function. So let's do y equals x squared again. There it is. Okay, now let's do y equals 3x cubed. Well, if you look at the table of values, 0 squared, well, you can give it 0. 1 squared gives you 1, times 3 is 3. 2 squared gives you 4, times 3 is 12. And the same thing was with the negatives here. Okay, so we have 0, 0. We're going to have 1, 3, negative 1, 3, and 2, 12. We're sort of off the graph here. But it's much skinnier, I guess you could say, than the other one. Okay, but we don't say skinnier. We call this a vertical stretch. It's like you're holding on to these ends here and you're stretching like an elastic band. You're stretching it this way. It's a vertical stretch. We call this a vertical stretch by a factor of 3. Okay, all the y values are tripled from the blue one. Vertical stretch by a factor of 3. Y equals negative x squared. Well, that's going to be negative 1 multiplied by all your y values from the parent function, which is the blue one. Okay, so negative 1 times 0 is going to give you 0. And here the y value is 1. If you multiply by negative 1, you get down here. And there the y value is 4. 4 times negative 1 is negative 4. So it's totally upside down. If it's negative, you have something like this. Okay, so we say this is reflected over the x-axis or reflected in x-axis. Okay, it's reflected in the x-axis. Now let's take a look at the next one. Half x squared. So you can take the y values of the blue function and multiply by half. So this is a 1 here. Well, first of all, 0. 0 is going to be there again. Half of 1 is half. Half of 4 is 2. Half of 9 is 4.5. So here's what our graph is going to look like. Okay, it's going to be wider, or some people say fatter than the original one. Y equals half x squared. So this is, you could say it's fatter or sometimes compressed or something like that, but we stick to the same vocabulary. It's a stretch, even though it's not really stretched out. We call it a vertical stretch. It's kind of like more like it's compressed, but we call it a vertical stretch by a factor of half. Okay? And if you had negative 8 squared, well, that's going to be reflected in the x-axis and vertically stretched by a factor of 8. We won't do that one. So A affects two things. A affects vertical stretch, and maybe we could just say negative A means it's reflected in the x-axis. It's a reflection. It's upside down. The parabola will be pointing down. Here's a summary. Yeah, so like I said, if A is positive, it's up. If A is negative, it's a downward facing parabola. And it talks about horizontal shift. Some people say shift, some people say translation. They're both okay. Yeah, so then you should be able to graph the functions yourselves now by looking at it, right? So this is vertical stretch. By a factor of 2/3. And then we have horizontal translation, 1 left. And lastly, we've got vertical translation, 5 down. Okay, we can put all that together. Well, first of all, and by the way, this is the form y equals ax minus h squared plus k, as we saw in the beginning. Because you have a horizontal stretch of h and a vertical translation of k, then hk is the vertex. So I might start with that. That's going to be negative 1, negative 5. Negative 1, negative 5 is where the vertex is going to be, right? It's positive. The a value is positive, so it's going to be pointing up. And we know it's a vertical stretch, a factor of 2/3, which is not going to help us too much in this case. I guess I could think you would actually have to calculate some of the values to graph it here. Okay. So we know like it goes over 1 and up 1. In this case, we're going to go up 2/3. And if we go over 2, we would go up 4. So what's 2/3 times 4? That's 8/3, or about 2 2/3. So next we're going to be going up from the bottom 2 2/3. Okay, and then we know the next point should be a 9. 2/3 of 9 is actually 6. So the next point is going to be up 6 from the bottom. So it's going to be right there. Okay, so I'm going to graph the parabola right there. And let me mention the axis of symmetry again. The line that goes straight down the middle, x equals -1, is called the axis of symmetry. Okay, and the vertex is another important point, -1, -5.